Hi everyone, I'm Ada. Welcome for joining our first webinar of 2019. Today, I would like to introduce about the public and the private IoT platforms. As the same as last year, if you joined us last year, to avoid interrupting of the webinar. So if you have any questions, please leave your question on the chat box. I'll reply you after the webinar. So now I'm going to mute everyone. So if you have any questions, please leave your questions on the chat box and I'll reply you after the webinar. Now let's start. I believe you may know, according to the development of the Industrial 4.0, the IoT market is more and more popular and more bigger than before. However, the key to gain the real business value from it is effective communication between all elements of the architecture to help you deploy your applications quickly and speed your data processing and analyzing. And finally, to help you to make correct decisions. The IoT can be divided as three parts: the device, network, and the cloud. The device means the end node, such as the sensors and a device that connected with the sensors, like the IoT gateway. And the gateway will collect all the sensors data through the network with the switch or routers to the cloud for the management. The cloud infrastructure contains large pool of virtualized server and storage that are networked together. So it's not only need a hardware device, but also the software integration for the data representation and management. From this picture, you can see the number of respondents adopting public cloud is 92%, up from the 89% in 2017. And the number private cloud is 75%, up from the 72% in 2017. As a result, both the public and the private cloud adoption has increased in the last year, up to 96%. It's very high. That means more and more people or companies are using the cloud application now. If you have been research about cloud platforms or cloud computing, you probably know the private and the public cloud debate. Before you decide which end of the debate you side with, it's very important to know the difference between the private and the public cloud. The private cloud can also known as the internal or enterprise cloud, resides on the company's intranet, where all of your data is protected behind a firewall. This can be a great option for the companies who already have expensive data centers because they can use their current infrastructure. Also, the private cloud offers a high level security. For the public cloud, you are not responsible for any of the management because your data is stored in the provider's data center. And the provider is responsible for the management and the maintenance of the data center. This type of cloud environment is appearing to many companies because it reduces the time of the test and the deployment. However, the drawback is that many companies still feel security could be lacking with the public cloud. This is the comparison of the public and the private cloud. As I just mentioned, the public cloud is hosted at the service provider, but the private cloud is hosted at an enterprise, the company. Public cloud supports multiple customers. The customer here means the companies. For example, Amazon AWS, the public cloud, can offer for many companies, and the private cloud only for your own company. Public cloud is connected over the internet, and the private cloud is connected over the private network, the intranet. So the public cloud is suited for the information that's not sensitive, but the private cloud is suited for the information that require a high level of security. Actually, OneMaster provides a smart cloud management. We support Amazon AWS and the Microsoft Azure cloud service. And we also have a provider recently semester the private cloud service. It supports a mobile stack to collect data from the mobile device. And it also supports interactive monitoring dashboard and map. It can show the device's status, signal strength, and the device's location. It also supports over-the-air batch device registration, configuration, and the firmware update. You can also set alerts on critical events to provide the downtime. For example, when the Wi-Fi signal strength is too low or the device temperature is too high. This is the SyncMaster Cloud Platform. OneMaster's SCP Smart City Box and the wireless products such as our WR series all support the mobile protocol. They can help you to collect the end device's data via the mobile communication, like the wind speed, emergency button, alarm, CO2, PM2.5, humidity, temperature, and even the radiation sensors. Besides, the SCP Smart City Box and our WR series also embedded MQTT and the RESTful API agent as an IoT gateway. So for transmit the sensors data to the cloud via the cellular network or Ethernet. All of the data transmission is secured by the TLS encryption and the X.209 authentication. And then the device manager can very easily to management all devices via the cloud with a high security. This is the feature that I screenshot from the dashboard. First of all, it supports multi-user management. Means each user can has his own privilege and the dashboard. So you can decide which user can edit or which user only have the view, can view the dashboard. And you can also configure the time range or refresh interval for getting the real-time information. As you can see here, you can set the time range as last 5 minutes, 15 minutes, or by hour, by day, or even by years. And for the refresh interval, you can set as every 10 seconds, 20 seconds, 1 second, or 1 minute, 1 hour, and so on. And for the analyze this log data, we support fast and flexible graph options. You can choose the display way what you like, the display way you like to help the data visualization. As you can see, this one, this is the graph option, the panel. As you can see, there are so many different types. You just need to use your mouse to click, and the graph you clicked will be created. And for alert, as I mentioned, you can make your own rules for important metrics. As this picture shown, you can make a CO2 alert when you over a certain value and trigger an alarm or send an email or SMS for you. And we also support GPS map tracking. If you only have a 1 or 2 or 3 devices, of course, it's very easy to remember the install location. In case if you have more than 20 or even 100 devices, this function will be a very good function for you because you can very easily to know the location via the map. And the real-time video stream can follow real-time surveillance. All the sensors data are also shown on the dashboard, including the trend chart. In addition, we support a VoIP voice broadcast. When the manager sees someone's change or there is a fire alarm, he can just press the VoIP button to ask the stranger get away or ask everybody to evacuate. This is the one-to-many broadcast technology. Means you can do the voice broadcast from the control room to the multiple field sites. And you can also install an emergency button on the field site. When someone faces an emergency event, he can just push the button and trigger the VIP for help. We also support RWD, responsive web design. So you can use your cell phone, your laptop, or your iPad to do the mobile management anywhere, anytime. And also, as I mentioned before, we not only provide the SyncMaster, the private cloud, but also the public cloud, AWS and Azure. They are the web GUI setting page and the layer dashboard. For the AWS, we use the Kibana, and the Azure, we use the Power BI. They both are very common dashboard for the AWS and Azure. Of course, if you want to use another one, or if you want to use another one, that's also fine for sure. And as the SyncMaster support many features that I mentioned, so it can be approached on the industrial 4.0 solutions, such as the monitor machine downtime, the duration, the occurrence, rotating speed, also utilization rate, and so on. And for the smart environment, it can monitor the air pollution like the PM2.5, CO2, or temperature, radiation, wind speed, and so on. And also for the water quality, it can monitor the water pH value, NH3, EC, DO, and so on. And you can also follow smart bus tracking to monitor the bus load, speed, and the oil or gas. Also, for the smart metering solution, we can monitor the power and the water consumption. For the smart farming, it can monitor the silos weight, temperature, and the humidity, and others values. And if you apply to the smart energy, it can monitor the meter voltage, frequency, power, current, and the energy consumption, and so on. Here is our SyncMaster systems requirement for the cloud server. Actually, to help easy installation of the server, we will provide a VM file, and you just need to import the VM file into your virtual machine. So please make sure your server or your PC is using a both Intel i5 4-core processor, and the RAM is more than 8 gigabit, and at least have the 20 gig free space. Okay, so let's follow SyncMaster your cloud servers requirement. Also for the SyncMaster, we support the SyncMaster OTA, the device management over the air. That means you can manage your device via the cloud technology. The SyncMaster OTA support interactive monitoring dashboard. And as you can see here, there is a map. In the map, we can display the device's location, status, and the wireless signal strength, the ISSI information. This is very useful for the moving vehicle application. From that, we can very easily to know the signal strength of the moving vehicles. It also supports over-the-air batch device registration, configuration, and the firmware update. As you can see, there are some checkboxes on the left side. So you just need to click the box, then you can do the batch management via the cloud. In addition, there is also an alert setting. You can set when the signal strength is too low or the device temperature is too high to prevent the downtime. SyncMaster OTA support multi-tenant architecture. A tenant can have many different projects. Different projects will have different users and devices. Each user will have his own dashboard based on the different privilege. This is a group and organized task for IoT deployment. Okay, this slide shows how to add a device into a SenseMaster OTA. This is the SenseMaster OTA management dashboard. So the first step is go to the device management and choose the add device. Then copy the access token to the device's website or web GUI. So after the security check, then you will find the device on the SenseMaster OTA. And also, according to the old device in the IoT is called thing. So we call it as a create a new thing. That's also why we called our cloud as a SenseMaster. For the device details, you can see the device model name, MAC address, firmware version, and the Wi-Fi signal ISSI, and so on. Also, you can find the device status on the map. As you can see, there's a map, and you found some icons. The green icon, green color means the device is active, and red means offline. Orange is in the warning state. That means there is something happen if the color is orange. You can also click the device on the map to see the detailed information of the device. So it's very easy. You can just click, use your mouse to click on the device, then you can see the details of the device. This slide is for the configuration and the reboot. As I mentioned, we support batch configuration. So you just need to select the device that you want to configure or that you want to do the phone upgrade, and drop your config file or your firmware file into the box and press OK. It will start to update your config or your firmware. And also, of course, you can do the one device reboot or firmware update or config for sure. This is the route map of the SenseMaster OTA. As you can see on the map, it displays the bus route path and the speed. You can also set an alarm for the overspeed to inform the driver and the manager. This is about the alarm log. When ISSI signal, the Wi-Fi signal is too low, or a car is over speed, or even someone press the push button on the field side, you all can see the alert here on the cloud. This slide is about how to add the alarm rule. As I mentioned, we can set like the ISSI, the Wi-Fi signal, and also the car speed, also the push button here. So we provide a very friendly rule engine for the alarm settings. That's called a rule chain. As this picture shown, here we have a default rule that's about the device info and logs. And they will be automatically created. And then it's the alarm rule, the right side, the alarm rules, and that's all what we can set. Here we have made the two alarm rules. One is ISSI, the Wi-Fi signal strength, and the other one is the speeding alarm. And actually we have, these days we have created a new one for the push button, and we can also support for the rule chain edit. So for these two files, you just need to click the plus icon, the red one, plus icon, and select the import rule chain. Then drag and drop these two files or the three files into a rule chain board, and press import. The rule will be added in. So after we added the two rules or added the three rules, now we need to connect them to our root rule chain. It's also very easy. You just need to drag and drop the rule chain block, the purple one, to the rule chain board. and select the alarm rule that we just created, the ICSI, the speed, or also the push buttons. After that, since the ICSI, speed or push button is keeping change by the time, so we need to connect them with the save time series, and then select success. The rule add setting is complete. Okay. Okay, for the default ICSI, the Wi-Fi signal, the alarm threshold we set is under minus 17 dBm, and the speed is over 100 kilometers. For the push button, is triggered by the DI. So if you want to modify it, you just need to click the rule change box. Then you can change the alarm value. As you can see, there's the numbers minus minus 70 and 100. So you just need to change the numbers if you want to change the rules. And this is our online demo site. If you are interested, you can scan the QR code for the experience. Here we have two demo sites. One is for a smart environment control room, and the other one is device management system. You can also find information on our website here. And actually, the big difference between the SyncMaster and the SyncMaster OTA is the SyncMaster is more focused on the field side information, such as the sensors data, and more for the administrator use. And for the SyncMaster OTA, it's more about the device management, such as the location, the device's location, the status, and also the check log. It's more for the management use. So now let's move to our demo site to see where it goes. So now I'm going to change the screen. Okay. So as you can see, that's our SyncMaster demo site we set from our office. As you can see on the left side, that's our site list. As you can see, we have lots of sites in our long-time office, and we also have a street light demo in our Taiwan office, and also Europe office, Xindian office, and also China Yancheng office, and so on. So in the left side, you can see the site list here. And also in the middle, there is the video stream here. And also you can see some sensors data like CO2, humidity, temperature, PM1, PM2.5, and PM10 values here. There's a real-time value we post here. And you can see under here there's a change chart of the CO2, and also for like PM1 to PM2.5, the air pollution values here. And also on the top, besides the time, you can see there is a current threshold as a CO2 alarm. That means when the CO2, the value of the CO2 is over the threshold we set, the alarm will be flash. As you can see a little bit on the video stream, just there is alarm LED layer. So since the value now is threshold is 1,000 and the CO2 is 1,176. That's over the threshold we set. So now I just going to change the threshold to 1,500. Later you will see the LED, the alarm LED will be off. Okay. And also here we have the voice switch. So if you, as I mentioned, if you see someone's change, you can just turn on the voice switch, the VIP buttons, then you can do the broadcast from the cloud. Since I don't have the speaker for the server, so I cannot do the voice demo for now. Okay, now let's change to the SyncMaster OTA. Okay, as I mentioned about OTA, as you can see, there is the device's information. As you can see, there is the model name, device name, make address, the firmware version, and the status active is false or the true is online or offline. And also the connection times here. And also for the map, you can see, give me some time to change the map. As you can see that we have the 3 devices here. Actually, it's 4 devices here. This is in our China Yancheng and also in our Taoyuan office, in Xindian office here. And the red means it's offline, and the green means it's active, online. And also we got the orange color, but not displayed here. The orange color means there is something happened. There is an event. There is a alarm triggered. And also for the bus route map, as you can see, there is a bus. Actually, we have installed a WR322G device in our business card. And this bus route, as you can see, there is in our Xindian office. And today, it went to the Xizhi and another place here. So you can check, you can see the bus route here. They went there and go back. Okay. And also there's alarms trigger alarm events here. So you can see there is some event like ISSI, the Wi-Fi signal, maybe it's too low. So we got some alarms here, and the alarm is be cleared. And let's see if I got some others. Let's push buttons. Okay, not here. And also, as I mentioned, you can do the click, like here. You just click it to see the details, information about the device here. So you can see, oh, let's offline. Okay, let's change the other one. Actually, you can see the information and the stress, signal stretch. Since it's offline, so there is no any values here. So let's go back to last page. You can click by the map, and also you can click from the device's information. So as you can see, there is our another device here, our Streamline device. So you can see there's a map location and also the details information and the signal strength here. And there is also alarm set, alarm informations here. Okay, so it's all about the ISSI. Oh, here, as you can see, there is an emergency button, the push buttons, alarms here. Someone push the emergency button. Okay, let's go back. And also on the main page, you can see the Wi-Fi signal for every devices here. Okay, now let's back to our slides. Okay, so let's also our online demo site. If you are interested, you can also go there to experience by yourself. The user's name is a Webmaster and password is Webmaster 101 for the semester smart environment control room. And for the OTA, the user's username is a Webmaster at webmaster.eu, and the password is also a Webmaster 101.